Let me quickly go over some of the other patterns also, and I'll start with the prototype pattern. The prototype pattern is very useful when we want the client to configure how objects are created. Let me introduce a client here whose purpose is to configure objects upon creation. So they want to determine how other clients create a particular kind of object. And I'm just going to call it the configurator. The prototype pattern suggests a very clever way to do such a thing. What you do is you introduce a shape that will act as a prototype. This shape's sole purpose is to be an example for other objects that we create. We have this familiar hierarchy that we've seen before with a shape as a base class and, say, a rectangle as a subclass. The actual prototype shape would, of course, be one of the concrete subclass types. So this prototype here could be a rectangle, for instance. The configurator will simply manipulate this shape and set the color, set the border width, or whatever properties they want to make this the default setting for all creations of rectangles. The way other clients would create rectangles now is by simply calling a method on the shape that acts as the prototype and ask that shape to clone itself. As a result of that, a copy is created by the prototype that has the exact same configuration as itself. And now a client can simply start using that copy. Because the clone method is polymorphic, we can now have the client basically talk to a shape that knows to be just one of the prototypes for a shape and use polymorphism to pick the right subclass. Now, you see this in tools like Visio. If you're on Microsoft, you've probably seen this, where you can grab a shape from the toolbar, and the toolbar is unaware of what kind of shape it is. And when you pick one of those tools and drag it and drop it onto your canvas, what happens is that the toolbar or the environment will call clone on that example object that exists inside the toolbar. So, a very clever little pattern for creation. We call this pattern prototype. And let's take a look at one more pattern. Let's imagine that we have some object that we need to create that is very complex. It may have a set of properties, or it may have a complex information model sitting behind it. Now, for a client to construct such an object is quite difficult. They have to have very intimate knowledge of how the object is constructed internally to be able to create a constructor with the correct parameters or pick one with the correct parameters. So, in short, our problem is we want to construct something that is very complex. The builder pattern suggests that in these cases that we introduce a special kind of object whose sole purpose is to aid the client to configure the complex object. As the client invokes methods upon the builder would know how to configure the complex object behind the scene. And we can make the builder interface very easy for the client to use. It could have things like set X, set Y, very simple methods. And finally, when the client has finished the configuration of the object, they call a method on the builder to get that object, which is now fully initialized. We call this pattern for the builder pattern. Now, I want to point out that for both of these patterns, in particular the builder, I recommend that you read the patterns book to get more of the details. There's a ton of tricks with the builders that are useful. For instance, using what's called a fluent interface so that you can chain the configuration commands. And there's a ton of other things that probably would be useful, but I just wanted to give you the general idea of the builder. So we're now seeing the factory method, the abstract factory, the prototype, and the builder. And the only one that is left of the 5 patterns that makes up the creational patterns catalog in the Gang of 4 book is the singleton. And I'll show you that one also to wrap things up.